Good morning. Today I'm going to go over plate tectonics and plate boundaries. And plate tectonics is a continuation of the continental drift idea, but it's kind of the next phase of that. So now we have better scientific instruments and we're able to study the inside of the Earth a little bit better. So plate tectonics is this theory that these plates that make up the crust of the Earth and the movement of those plates, or the movement of the crust, if you want to think about it like that, are what cause the different landforms and different geologic features that we see on Earth. And these are things like mountain ranges, volcanoes, earthquakes, rift valleys. All these things are created by plate tectonics. And that's what you see here. This is just a basic diagram of two plates coming together, which we're going to talk about soon. But when they do that, they create this chain, this mountain range right here with volcanoes. It's a volcanic arc. And one of those plates goes under the other. So in the map that we have of the Earth, you can see the plate boundaries. So this is the crust of the Earth under the continents and under the ocean. And it's broken up into all these pieces. And what it looks like, or what people often kind of describe it to be like, is an egg. Like if you have an egg and it's all cracked and broken, but not all the way open yet, that's kind of what the crust of the Earth looks like. All these plates that are all pushed up against each other, but we have these huge cracks that separate one plate from another, okay? Now, when I say that they're all pushed up against each other, we have to remember that they're also constantly in motion. That's what you're seeing here. Is in this image, it shows the different plates and the different directions that they're moving in. And some plates are moving faster than others. It just depends. Because underneath the crust, underneath these plates, it's all liquid rock, right? It's magma, and that stuff's moving underneath, and some of it moves faster than others. So some plates move faster than others. You can tell the quick moving plates have these long arrows here. Like this is the Pacific plate. And then there's some slow ones, like the Antarctic plate, have these short arrows. They're not moving as fast, okay? But remember, they're pushed right up against each other. So when these plates are moving past each other or towards each other, there's going to be a lot of things that can happen in the Earth, things that we can notice and see. Again, volcanoes and earthquakes are a good example, but there's other ones. So there's three types of boundaries where the plates meet and touch: divergent, transform, and convergent. So let's go over those. Divergent is a boundary where two plates are pulling apart. So they're going in opposite directions. And as they pull apart, magma from inside of the Earth can actually come up and fill in those cracks. So this is how we make new crust. Or new, a lot of times this is on the ocean floor, new ocean floor. And you can see it starts up at the top. They start moving away from each other, divergent. This magma is close to that thinned out part of the crust, and it slowly seeps through and makes these in this case, underwater volcanoes, which create new land. That's how we get new land at divergent boundaries. Now let's take a look at the other two. So the opposite of divergent is convergent. In a convergent boundary, the two plates are moving towards each other. So when I say that, this should automatically cause a problem in your head, because if two pieces of the crust are moving towards each other and smashing into each other, what is going to happen there? Something has to give, right? Something has to move up or down or pile up. And what we see is that there is actually some pretty dramatic things that happen at convergent boundaries. They're between the two plates. So here's one plate over on this side, and here's another plate over on this side. Between the two of them, one of them is going to be more dense than the other. And generally speaking, the oceanic crust is going to be more dense than the continental crust over here, which is less dense. Because of that difference in density, the higher density plate or crust will sink under the lower density one, okay? This is how we get crust to become recycled. So all of this rock and crust right here is going to go back down into the earth and remelt into magma. It's going to get recycled. And then finally, we have a transform fault. So this is when two plates are sliding past each other. And as they slide past each other, they're not smooth. They're very rough, and they get stuck and they grind past each other. And when tension builds up as they're trying to slide past each other, that tension builds up. When it's released all of a sudden, that's what an earthquake is. So the classic transform boundary is the San Andreas Fault, which causes all the earthquakes in California, all these big earthquakes that you'd hear about in California, mainly from the San Andreas Fault and small faults around it. Okay, I hope this helps. Thank you.